I'm going to open up our employee because what it was asking us to do in this exercise was to clean up our code. In exercises previous to this one, when we look at the various constructors, what we'll find is that there's a lot of redundant code. Each of them set their own values based on the argument list that we gave it. Well, once we start to make code redundant, it becomes more and more difficult to maintain. It's better if we can borrow or use existing code to our best advantage. To do that within a constructor, we'll use the flavor of the this keyword as a reference to another constructor. Let me explain that with an example. Look at line 14. There we have a constructor that takes a first and a last name and a department. If I were to look at line 10, I can see I already have a constructor that will take the first two arguments. I'd like to use the code that's on lines 11 and 12. I'd like to keep reusing that and not repeat it in the constructor that we see on line 14. So what I'll do is use the call to the constructor using the keyword this. Notice after this we have, I'm looking at line 15. Notice after this, which is a reference to the constructor, we have a first and a last name argument. In other words, I'm chaining these two constructors together. The constructor on line 14 finds this constructor, and it will call the one directly above it, namely the one that will set the first and the last name. Now, the only thing that the line 14 constructor has to do is to set the value that was not part of that first constructor, and it's doing it on line 16. It's simply saying, okay, let me set the depot or department as well. All right. The same rule holds as we move down the list of all of the other constructors. Each one has a reference that leads us to a former type of constructor. The one that we're looking at on line 22. On line 22, I can see that I have the full measure of arguments to the constructor. The first, the last name, the department, and the pay rate. The only thing that we need to set here that's not in any of the other previous constructors is we need to set the pay rate itself, and that's exactly what we're doing on line 25. Let's follow the flow of programming from this constructor. On line 24, we're referencing another constructor that takes a string int. So I find that constructor is on line 14. The first line of that constructor calls the constructor that only takes the first and the last name. So we chain now to line 10. Line 15 of our constructors and 16 take care of setting the values now for the first name, last name, and department. Back on line 25, we simply return now and set the value for the pay rate. Now, what we have is a series of methods that actually call one another. This keyword is used in Java in this flavor as almost looking like a method call. It uses it to reference another constructor. There's a rule around this. When we use this keyword as a reference to another constructor in a class, it must be the first line of the constructor itself. So in each case where we're using this, notice that it is always the first line of the constructor in which it's defined. Right. There's another usage for this. Just as the keyword all by itself. I'm moving down the page to get an example of that. Let's look at line 32. On line 32, we have a method that takes a parameter first name. We want to set the value of first name for this class. As we see it as a parameter, if you remember, that's a local variable. It'll go away as soon as this method is finished being called. We'd like to make it persist so that we can use it. And for that, we have a instance level method variable. And you can see up on line 3, we do have a first name. Our problem, I'll go back down to that method. Our problem is that we have a naming collision. The local variable first name is the same as the instance variable first name. I can reference that instance level variable specifically by tucking this in front of it. So on line 33, what we see is that we have this dot first name that references the instance variable. And then we have just the plain old naked first name on the right side of that equal sign, and that references the local variable. Where naming conventions collide, the local variable wins as a default variable. So as a result, the instance variable needs this modifier so that we can disambiguate the naming. If they were both different names, if, for instance, this parameter that's being sent was called FN, just the short name, then it would be first name equals FN, and we could drop the if because there's no ambiguity between the naming conventions. It's normally considered to be good practice to maintain in the getter and setter methods to use the variables as part of the argument that are the same as the instance variables. One reason for it is that a lot of IDEs will have a self-complete or an autocomplete type feature. And when we see the signature of the method pop up, it tells us what variables we're actually taking care of and what kind of parameters they might take. All right. In order to use this new employee that we've developed, we're taking advantage of that in our payroll class again. The main method in this payroll class uses several of our constructors to build a number of different employee types. Now we have 4 employees. We have the first employee on line 3, and that has no arguments. So we need to set them all up. We have to physically set those values, and that's what we're doing on lines 4 through 7. And then we print the value out at line 8. Employee 2 on line 10 uses the former constructor. It allows us to simply set all of the values of that employee as an argument list. And again, we'll print that employee out. On line 10, we're making a call to another constructor that doesn't have a department. And on line 16, we're making a call to the employee where we don't have a pay rate. Let's give it a run. And I'll compile this. All of the Java there. And now we'll run it. And what I can see are all of the employees that we've created. John, Jane, Bob, and Bill They all have the appropriate values. We still have no value for Bill in regard to his ID or the pay rate. Equally, for Bob, we don't have a department, so it defaults to 0. Okay. Now that takes care of our review of this exercise. And what we'll move on to is working with static elements in your next reading. That's another funny concept in Java. That keyword has a lot of ramifications. So go on and do your reading, and we'll talk again.